Hi everyone. So in this class, let's discuss about subnetworks, the concept of router, which we introduced in the last class, how packet travels from one subnetwork to the other subnetwork, what's the logic behind the router, and routing table, and all that. So let's discuss. So in the last class, we took an example from class C 200 dot 1.3.0, and we divided this network into two networks. So we divided it into subnet 1 and subnet 2. So subnet 1 has IPs from 200.1.3.0 to 200.1.3.127, and subnet 2 has IPs from 200.1.3.128 to 200.1.3.255. Here in subnetwork 1, the network ID of the network is 200.1.3.0, and DBA directed broadcast address is 200.1.3.127. So the first IP is always given to represent the network or the network ID, which is 200.1.3.0, and the last IP of the network or the subnetwork is given to the directed broadcast address. Here in on subnetwork 1, it is 200.1.3.127. So the total number of hosts here in subnetwork 1 is the total IPs we can get in subnetwork 1 is 128, but since the first IP is given to the network ID and the last IP is given to the DBA directed broadcast address, the total number of hosts on subnetwork 1 is 128 minus 2, which is 126. Similarly, on subnetwork 2, your network ID or the network is 200.1.3.128, and your directed broadcast address is 200.1.3.255, and the total IPs you can get on this subnet 2 is 128, but the total hosts you can have is 128 minus 2, which is 126, as the first IP is used to represent the network subnetwork 2, which is 200.1.3.128, and the last IP is used to represent the directed broadcast address, which is 200.1.3.255. Suppose you have just the network, and you have now divided it into two subnetworks, subnet 1 and subnet 2. You take it as one network, 200.1.3.0. Then the number of IPs available for the entire network is 256, but hosts available are 256 minus 2, which is 254. But when you divide it into two networks, subnet 1 and 2, total hosts available are only 126 from subnet 1 and 126 from subnet 2, which is 252. So you are wasting two IPs here, because you have the total number of hosts available here are 254, and total number of hosts available here are 252, as one IP here was given to directed broadcast address for subnet 1, and one IP is given to the network ID for the subnet 2. So one more small disadvantages of subnetworking is the wastage of the IPs. Suppose in this case, when you are dividing it into two subnetworks, you are wasting uh, two IPs, the total four IPs. If you take it as an entire network, you are wasting two IPs, and if you are dividing it into two subnetworks, it's 252, 256 minus 252, we are wasting four IPs. And let's discuss the concept of router now. So as we discussed in the previous lectures, when you select one bit in the host ID part, you can divide your entire network into two parts, as we discussed in the last example. Suppose if you select two bits in your host ID part, you can divide your entire network into four subnetworks. So let's take the same network and I'll give you the example 200.1.3.0. In the previous class, we selected one bit on the host ID part, 0 on the subnetwork 1 and 1 on the subnetwork 2, and we divided it into two subnetworks. Here I'll select the two bits in the host ID part. So here 200.1.3.1 2 3 4 5 6 7 8. I will select two bits in the host ID part 0 0, and here similar way 200.1.3.1 2 3 4 5 6 7 8. I'll select two IDs and I'll give it as 0 1. Here similarly I'll take 1 2 3 4 5 6 7 8 2 and I'll give it as 1 0, and here 1 2 3 4 5 6 7 8 I'll give it as 1 1. So it starts with the range starts from all zeros in the all zeros in the host ID, which is 0 0 0 0 0 0 till 1 1 1 1 1 1, which is from 0 to 63. So the range here is from 0 to 63. Similarly, the range here is already the first two bits are fixed, which are 0 to 1. So if you start from all zeros in the next 6 bits to all ones in the next 6 bits, here your range is 64 to 127. See, this is suppose subnet 1, subnet 2, subnet 3. Here if you start with all zeros in the 6 bits to all ones in the 6 bits with 1 0 as two IPs fixed, two bits fixed, here it starts from 128 to 191. Similarly, here the range is from 192 to 255. So here you are selecting the first two bits in your host ID part. Since you are selecting two bits in your first two bits in your host ID part, you are dividing your entire network into four parts, four subnetworks: subnet 1, subnet 2, subnet 3, and subnet 4, with range in subnet 1 from 0 to 63, 64 to 127, subnet 3 128 to 121, and subnet 4 is 192 to 255. And let's represent it with routers and interfaces and see how the packet travels from one subnetwork to the other subnetwork. So let's represent the same network 200.1.3.0. I'm dividing it into four subnetworks: subnet 1, subnet 2, subnet 3, and subnet 4. And let's, as I told you in the last class, let's put an internal router here. Let's call it as interface A. Let's call this one interface B. Let's call this as interface C, and this interface D. And there is an external router provided by your ISP, and let's call this as interface E. So let's talk about how your network travels from one subnetwork to the other subnetwork. Before going into the four subnetworks and how the packet travels from one subnetwork to the other subnetwork, I want to give you a simple example with two subnets and explain you how the how packet travels within a network, and if someone sends it from outside the network. So let's take a example, a simple example. Before we go into four subnetworks, I want to give you a simple example by taking just two subnetworks and explain you something. So suppose you have a network and you are dividing it into two subnetworks, subnet 1 and subnet 2, with two interfaces A, B, and you have your external router provided by your ISP, and it has its own, subnet 1 has its own network ID and directed broadcast address, and subnet 2 has its own network ID and directed broadcast address. And you know that the direct dba of S2 is same as the entire network. It's same as the entire network. And network ID of subnet 1 is same as the network ID of the entire network. Suppose someone outside the network is someone is outside the network and there is someone inside the organization. So if someone wants to send a packet using the directed broadcast address of uh, subnet 2, does the packet reach to all the hosts in the entire network, or just the subnet 2, because the direct dba of S2 is same as the dba of the entire network. So it depends on the perspective whether you are sending your dba within the network with someone sitting inside the network or someone sitting outside the network. Suppose if someone sitting the outside network and uses his destination address as a DBA sitting outside the network, then the packet is sent to all the hosts in the network. If someone is sitting inside the organization and if he is using the destination address as the DBA of S2, then it is sent to all the hosts in subnetwork 2. And similarly, if someone sitting outside the network and if he uses the destination IP as the network ID for the entire network, then it is sent to this network, the network, the entire network. If someone is sitting inside the network and if he uses the destination address as the network ID of subnet 1, then it is sent to S1 using a interface A. So this is the simple example to just give you the idea how a network, how the packet travels using the directed broadcast address. If the person is sitting outside the network or if the person is sitting inside the organization, and he uses the same DBA for S2 or the entire network, or same network ID for the entire network, which is same as the network ID for subnetwork 1. And let's go back to our example here where we divided the entire network into four parts: S1, S2, S3, and S4. Subnetwork 1, subnetwork 2, subnetwork 3, and subnetwork 4. And your network is entire network is 200.1.3.0. So as we discussed a few minutes ago, the subnetwork 1, the range is from 0 to 63, and subnetwork 2, the range is 64 to 127, and subnetwork 3, the range is 128 to 191, and subnetwork 4, the range is 192 to 255. Suppose someone wants to send a packet to, suppose, subnetwork 3. Take IP 200.1.3.130. To this IP, someone wants to send the packet or from outside. So it has to take the this way network interface C, then it has to go to interface C to go to subnetwork 3. But how does a router know that it has to take interface see, and once it enters the network 200.1.3.0, how does the router know it has to take interface C and reach subnetwork 3? Here comes the concept called subnet mask. So subnet mask is nothing but the concept or the logic used by the router to decide what interface it has to use to send the packet to the destination IP. So the concept used here is the subnet mask gives the router the network ID where it has to send the packet to. Suppose here, if someone wants to send the packet to the IP 200.1.3.130, the router uses the logic of subnetwork and decides its interface C and sends it to subnetwork 3. So here the subnet mask use the router that it has to send to subnetwork 3. So it has to send to the network 200.1.3.128. This network ID the router gives using the subnet mask concept. So subnet mask is nothing but it is a 32 bit of same that for the regular as a regular IP, 32 bit of zeros and ones, where your network ID and the host ID has all ones in it, and your network ID and your subnet ID has all ones in it, and your host ID has all zeros in it. So subnet mask the has all ones in your network ID and subnet ID and zeros in your host ID. Here, if you are dividing it, you are dividing your network into four parts. Your subnet ID has 2 bits in 2 bits, right? So as I told, here you have your network A, B, C and D. Here the range is 0 to 63, 64 to 127, 128 to 191, 192 to 255. And as I told, subnet mask is a concept used, the logic used by the router to decide the network where it has to send the packet to. So our destination IP is 200.1.3.130, 130. So as I said, your network ID and subnet ID has all ones, and your host ID has all zeros. You are dividing your network into four subnets of equal sizes here, and as we discussed before, we select 2 bits in the host ID part to divide the network into four parts. So your network ID and the host subnet ID here has, so here your network is 200.1.3.0, and here your network ID here is this one, and you are selecting 2 bits as your subnet ID and other 6 as your host ID, right? These two are you are selecting to divide your network into four subnetworks, and these are your network IDs. So by the definition of subnet mask, all the network IDs and subnet IDs should have all ones. So it's 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. dot 1 2 3 4 5 6 7 8 dot 2 ones in the SID, 1 2 and zeros, 1 2 3 4 5 6. Entire this thing is your network ID. This one what I'm talking about, and these two are your subnet ID, because you're selecting two to divide it into four networks, and this is your host ID. So you here the router knows that you are selecting 2 bits and it has a equal length of 4 subnetworks. So the router knows the subnet mask is what's given here, which is 255.255.255 dot, this one here is 192. So the router knows the logic that my subnet mask is here 255.255.255.192, because you have four networks. It's divided into four subnetworks of equal length. So here your network ID, as I told you, is, I mean, the subnet mask, you got it as 255.255.255.192. So the concept here is when you and you want to send your packet to the IP 200.1.3.130. The concept here is when you and your subnet mask with the IP where your destination IP, you will get the network ID of the subnet you want your packet to go to. So as we discussed, here you have four networks, right? Router here, router here. Here the range is 0 to 63, 64 to 127, 128 to 191, 192 to 255. So your destination IP is this one, 200.1.3.130, which is subnetwork 3 here. You want to send it to subnetwork 3. So how does the router know? I told you, right? You need to AND your subnet mask with the destination IP for the router to know it's subnetwork 3. It gives the ID of S3. So let's see how it works. So your subnet mask is 1 dot 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8, and here it's 1 2 in the subnet ID, 1 2 3 4 5 6, and your destination IP is 200.1.3.130, which is 1100.1000 dot 1 2 3 1 dot 3 is 1 2 3 4 5 6 1 1 dot, here it's 130 is 1 1 0. If you add this, when you add anything with 1, it's the same number, which is 1 1 1 2 1 0 0 0. Same thing, 1 2 3 4 5 6 7 1 2, and here when you add 191, it's 1 190, it's 0 1900. So you get your network ID here. So this is same 200.1.3.10000 is 128, which is subnet of S3. So the router here ANDs the subnet mask with the destination IP to get the network ID of S3, so that it knows that it has to use interface C to reach subnet 3. So here you got the network ID of ES3, so the router knows it has to send the packet to from here to subnet 3. So it comes from the external router to S3. when you AND your subnet mask with the destination IP, you get the network ID or the network where the router has to send the packet to, which is subnet net 3 here. This is the logic which the router uses. Let's give you an example here. So so let's give you an example with a routing table here. So you have your router for networks, and we call this as interface A, interface B, interface C, and interface D. This is subnet 1, subnet 2, subnet 3, subnet 4. Subnet 1 is 0 to 63, subnet 2 is 64 to 127, subnet 3 is 128 to 191, subnet 4 is 192 to 255. So let's take a table here. Suppose you have your network ID. I'll give you some examples. Your subnet mask, interface. Suppose your network here, for the first subnetwork S1, your network ID is 200.1.3.0, and your subnet mask is 255.255.255.192. So whenever a packet wants to send to subnetwork 1 or to any IP in subnetwork 1, it ANDs the subnet mask with the IP in the subnetwork 1 to get the network ID 200.1.3.0, and the interface is A. Similarly, if someone sends a packet to one of the IPs in subnetwork 2, it ANDs the subnet mask 255.255.255.255.192 to get the network ID of subnet 2, which is 200.1.3.64, to send it to interface B. If someone wants to send a packet to subnetwork 3, then it ANDs the same subnetwork, the logic 255, 255, 255, 192 to get the network ID 200.1.3.192, which is network interface C. Same for subnetwork 4, ANDs the subnet mask to any one of the IPs in subnetwork 4 to get the network ID 200.1. Sorry, here it's 128. 128. Here its network ID for the subnet 4 is 192, which is interface D. So it's nothing but the logic here is it AND subnet mask with the IP in particular subnet to get the network ID of the particular subnet, so that the router knows where it has to send the packet to. Suppose if it doesn't match any one of the network ID, subnet 1 or subnet 2 or subnet 3 or subnet 4, what that means it is it doesn't belong to the network, the entire network. If it doesn't match to with any one of the network ID of S1, S2, S3, S4, then it doesn't belong to the network, and it's called the default entry, which is 0.0.0.0, because if it doesn't match your network ID, gets when you add the subnet mask with IP which is not in the network, you get all zeros. Default entry, that means it has to send the packet out of the network, which is interface E. And here in this lecture or the previous lecture, we selected either 1 bit to divide the entire network into 2 networks, or 2 bits in the subnet ID to divide the entire network into 4 networks of equal sizes. This is called a fixed length subnet mask. In the next class, we'll discuss about the variable length subnet mask, which is called VLSM.